Okay, welcome back, Dartmouth. Hopefully by now you know what we're doing here. Um, Today we are going to learn about the characteristics of scientific knowledge. Hopefully you already have your notes set up in the Cornell style. And so let's get going. All right, here's our EQ. What investigations do scientific investigations involve? Well, scientific investigations involve observing. They involve collecting empirical evidence. They use logical reasoning. We can make inferences, but we can also apply our imagination. So let's first talk about observing. We know that an observation means that we are using one or more of our senses to gather information. And so observing is just that whole process of gathering information. And from that, we can draw scientific conclusions. Now, specific information is recorded during observations, and that is called data. Those are the facts, the figures, any other evidence that might have been collected during your scientific investigation. Now, when data are collected in a precise, logical, consistent manner, it's called empirical evidence. And so, again, that empirical evidence is just data and the observations that have been collected through a scientific process. All investigations, scientific investigations, involve the collection of relevant empirical evidence. And that empirical evidence is going to hopefully support the researcher's conclusions. Now, of course, we have to use logical reasoning. When we collect data, we review those figures, and we look for patterns that help to explain our observations. We use logic, we use reasoning, and then draw conclusions based on the patterns we see. We can also make inferences, and that means explaining observations. But again, it's got to be in a logical manner. So we're going to draw conclusions based on what we already know. And so if you take a look at the picture, what can you infer from this picture? Hopefully it's that it's probably cold out. But we can also apply our imagination. And that's an important element. It helps scientists to design experiments. It allows scientists to solve scientific problems and to see patterns in the data that maybe nobody else has been able to see before. Okay, so that brings us to objective versus subjective reasoning. Objective reasoning is based on evidence because, of course, scientific reasoning relies on gathering and evaluating evidence. Subjective is based on personal feelings and personal values. And so we try to keep subjective out of scientific investigations. And of course, we have science versus pseudoscience. Pseudoscience, pseudo, false, is a set of beliefs that make use of science, but the conclusions and the predictions are not based on observations, objective reasoning, or scientific evidence. Remember, science is based on empirical evidence and well-reasoned interpretation of the data. Pseudoscience might make use of scientific data, but the conclusions are subjective, so they're a little faulty. Now, understanding other aspects of the world requires training outside of science. For instance, philosophy, trying to discover the meaning of life, reasons for historical events, appreciating works of art. Those types of things cannot be explained or taught by science. So what does characterize science and its methods? Science and its methods are characterized by an ordered approach to learning, where again, we are talking about objective analysis of data, well-reasoned. Those experiments can be repeated and confirmed. So again, it's a very logical step-by-step method. Okay, I hope this helps you understand a little bit more about the characteristics of scientific knowledge.